On Friday, we talked about 1 and 6 had the same solution. Did you guys find any more that had that same solution? Are there any others that wound up with 7/4? Not 2. 2's really close though. What 2's was, 2 was negative 7/4. Yeah, 5 also was 7/4. This one. These ones were all positive 7/4 if we finished simplifying down. How about with number 2? Did we find anything else that was negative 7/4? 4 was also negative 7/4. 3 was kind of on its own. 3 was 11/3. Okay, so what they were trying to get us to see is what we talked about on Friday, how this one is really this one divided by 10. On these ones, they took and like flopped a couple of pieces and doubled it. But how they expect us to see that is just a little much. It's a little much. But that's what those were. And we kind of started talking about that on Friday. And I gave you guys a whole bunch of time to work on that. So thank you for having answers for that available. I appreciate that. So what we're really going to talk about today is the next page. Task 6. It's called equivalent or not. And what we're doing is we are not finishing these. This is really what the first homework is very much like, I believe. I'm pretty sure it's very similar to this. Did they do something that you're allowed to do in the math rules to get from here to here? So we got to try and figure out what they did and is it allowed. So look at these two statements here. This piece and this piece. How did they go from here to there? They added the 2x to both sides. Is that something we're allowed to do? Can we add 2x to both sides to things? Yeah. What this is that's called using the additive property of equality. It has like fancy names. I'm trying to put the page numbers. All the property names are in your book. I don't expect you guys to memorize them, but 31 and 32 have all of the math rules in them. We're not going to be doing proofs needing to do the properties, but they're there if you're wondering what it's for. But yes, this is valid. And if you care, it's by the property of equality for addition. You can just put a plus. Property of equality for addition. It means as long as they do the same thing to both sides, I can do whatever the heck I want when I'm adding stuff. Same thing with subtracting stuff. I can subtract whatever the heck I want from both sides. So then let's look at the second one. We want to see what did they do and are they allowed. So how did we go from this one to this one? Because I know sometimes they get really smushed together there. What'd they do? Yeah, they kind of dropped that 3. We didn't like the 3, we threw it away. So we dropped the 3. Is that allowed? Can we do that? What should they have done instead? They could distribute the 3. What else could they have done with that 3? What's another way we could get this 3 to move? What operation is it between the 3 and the parentheses here? How do we undo that? Divide it. We could also divide by 3. As long as we divide both sides by 3. So you can divide both sides by 3. But we can't just go, I really don't like that 3 out in front, and just like boot him. Not allowed to do that. I feel like this next one's the hardest one. What did they do to get from here to here? Do they mean the same thing? What'd they divide by? They divided by x, really. To get from here to here, they divided by x. Are we allowed to divide by x? No. Think about when we were doing x squared stuff back in algebra. Whenever we're trying to solve an x squared, what does it need to equal? Remember? It's been a minute. 0. Whenever we're solving an x squared, it has to equal 0. I can't just go from here. Because how many solutions should this have, an x squared? X squareds get 2 solutions. So we can't just say it's equivalent to x equals 6. X equals 6 may be a solution, but x equals 6 only has 1. It doesn't have 2. So those 2 things are not equivalent. We are not going to divide by x ever. We can add and subtract x's. We are not going to divide by x to try and make things nicer, because that's cheating. You lose the solution. Same reason we're not going to multiply by x. Granted, that would only really make life harder, but we're not going to do that either. And then look at this one. What happened here? What did they do? This may be exactly what I just said we probably weren't going to do. What happens when What'd they do? They multiplied by the denominator, right? To get this guy up, they multiplied by denominator. In the rare case, we are given an x in the denominator. We can multiply by that. It's going to be super rare. This was them trying to trick us, and me genuinely forgetting that one was on the page. Is that something we're allowed to do, to multiply by the denominator to get rid of fractions? What if it was just a 5 under there? What if it was 1/5 x equals 10? Could I then multiply by 5 to get rid of that denominator? Yes. Can I do it even though there's an x inside of it? Yes. When you have a fraction like that, For the most part, we're going to be able to do this. It would be very rare that we can't, because we are not going to see much of those. We saw those occasionally in Algebra 2 near the end of the year, but we should not see bunches and bunches like that. This was them liking to play games with us and show us stuff that's really, really hard. Okay? So the point of this is to see, do these things mean the same thing? Are they a valid operation? Yes, we can multiply by the denominator. No, we cannot just divide by an x because we don't like it. We can multiply by the denominator. As long as there is a reason for it that is a valid mathematical thing, we can do that. So what you're going to do is for the rest of the day, you're going to work on homework 2-1. If you have not started it on Canvas. 2-1 is, I believe, called equivalent expressions, but I will pull it up and double check. Because there's some of us, I need us to go in and like start doing homework. There's not much in this class. I think there's maybe 16 in the semester. There's not much. It's less than 1 a week. My Canvas is being aggressive. 2-1, does it match the equation? What is it called? Yes. Give me just 1 second. So you're going to go 2.1. Does it match? Now is also a great time if you're one of my friends that has like none homework done. Now it's a great time to catch up on that. But 2-1 is thinking about story problems and does the equation match the story? Okay? So looking at them, we started looking at story problems and stuff last week. Does it match? Reminder, I gotta do attendance too. And you guys can like talk to each other. You guys can work together. You can ask me questions. That's one of the benefits of doing this work here. Is you have resources available. There you go, dear. You could also do 2.2. Unit 2, homework 2 was the one I was thinking of for today. But you can do both of them. Equivalent expressions is unit 2.2. You can do both of these. You should work on them. You guys have a half an hour in class. You shouldn't have to do any of the homework for this class at home. And that will continue to be true for the rest of the year. You have time in this class to do it. You never have to do homework at home. We have the next two this chapter will have a regular test, but the 2 chapters after that are going to have projects that you'll have time in class to do. So like you don't have to do anything for this class at home. So work on this stuff now. Ask questions. I'm here. You guys have the time. Let's not hurt the grades on purpose.